Hey physics students, this is Dr. Charlie coming to you from my basement. This is going to be our first virtual lab. Um, this is for Thursday, April 2nd, I guess. Okay, so not we're still going to use a lot of the stuff that we do in lab. You're going to do the lab write up in Microsoft Word, and then you're going to save it as a PDF, and then you're going to submit it on Blackboard, just like we have been with labs all semester. So go to course content and then click on the lab tab and go down to lab 7 and click on that. It's got a Word document attached to it, so I'm going to click on that and I'm going to save the file, and I'm going to save it on my desktop. I've already got one there, so I'm going to replace it. Then I find it on my desktop and double click on it and open it. And here it is. I'll type in my name. Once again, let's put the stuff I'm typing in a different font. You know how I like that. I like green today. So I'm going to type Charlie. You would type your name here. And then section. You're in section 601. And okay, so now here's the website that's going to have the simulation that we're using. This is the called Atwoods Machine. It's just two weights. One of them is heavier than the other, and a pulley. And so this heavier one is going to move down this way, and the lighter one's going to move up. And there's usually a ruler here to measure distances. And you measure how much time it takes for this to go a certain distance. And we're going to start with Newton's second law of motion. Oh, that's easy enough. F equals ma. And okay, so now we're going to draw a couple of force diagrams here. This is kind of neat. This lab was made up by a lab guy at Florissant Valley. I like it. Name is Tony. We're going to, it looks like M2 is a heavier one here in this picture, so we'll go with that. So I'm going to draw the forces on each of these individual masses and label them. And I'm also going to label which is the positive direction. The direction of motion I like to choose as the positive direction. So it looks like M2 is got a bigger weight in that picture. So I'll put this M2G acting downward on mass 2. See, this is the force diagram for mass 2. And look, these two forces are the same length. I bet those are the tensions. So I'm going to put the tension force here and label that T. And the direction of motion I want to label as plus, so I'm going to call the positive direction downward for this mass. And then you have to do the rest of those. I think I want you to think about it a little bit. Write Newton's second law for M1. And then write Newton's second law for M2. Okay, I'm going to do M2. Then you can do M1. So what would I say? It looks like M2G minus T equals M2A. And you'd have, in number 3 here, you'd have a similar Newton's law for block number 1. And then solving those two equations, I would add them together so that the t's go away. Solving the two equations, I want you to show your work here. I'm going to tell you the answer because I've seen this so many times. solve for the theoretical acceleration. So let me get my colored font here. So the acceleration that you're going to get will be m2 minus m1, if m2 is the heaviest, divided by, parentheses, m2 plus m1, times g, all times g. That should be the answer you get when you solve these equations in 3 and 4. All right, now we're going to go to the actual experiment. We're going to need this equation here, I think, A. For A, open Atwoods Machine, hold down Control and click this. So it should open up in a Control click. I just did it. And you should get this. This is not quite Atwoods Machine here. This is something like it. Of course, it's got a little car up here and a hanging weight. If I click on this, it starts. Oh, that was cool. Okay, what does it say to do next? Let me find my... click on the smallest red mass, and it will turn into this picture here. So let me go do that. Click on the smallest red mass. There it is. Oh, now it turned into Atwoods Machine. Let's start it up here. Oh, here. This makes it bigger. And here's start. Oh, I guess I got to do something else. So I do escape to get out of that full screen. Go back and look at the directions. Click on the center blue mass. That's 2 kilograms. And then click start. So I'm supposed to click on the center blue mass. So I'll go back to it. Click on the center blue mass. All right. And start. Whoa, they got the heavier one on the right instead of the left. So this would be the heavier one over here on the right. And it took 1.14 seconds to fall 2.1 meters. How do you get it back to... I just pulled that down. That's how you get it to do it. 1.13 seconds to drop 2.07 meters. So this is kind of fun. You just use your hand there to drop it down. Cool. All right, escape to get out of that, and then go back and read my directions. We're supposed to put the displacement and the time, and then use the larger blue mass. So I'm supposed to go back here and do it again. Make it full screen. I'm going to use this larger blue mass. I bet it's going to take less time to fall. Start. Whoa, 0.92 seconds to go about the same distance. Start it over again. Whoa, cool. Oh, I definitely like that. So I'm supposed to record the displacement and time I get. Use these values and the kinetic equations to solve for the acceleration in both setups. Okay, the acceleration equation you're going to use is that distance equals 1/2 at squared. You see, I know the distance in each of these things, and I know the time, so I'm going to use this to solve for a. So I'm going to use this equation. I'm going to use these values. So I'm going to use these values for displacement and time to calculate the 2 accelerations that I would get. And I'm going to put those in here for the experimental accelerations. And then I'm going to use the values of the 2 different masses. 1 kilogram for the red mass and 2 kilograms for the heavier mass in this case. And I'm going to calculate the theoretical acceleration from this. And I'm going to fill that into the results table. Then I'm going to answer these questions. Okay, then I'm going to do a save. Then I'm going to do a save. And then I would do export to PDF. Export as PDF. This is Open Office. Word's a little bit different, of course. So I'm exporting it to my desktop. Then I would go back, just like we have all semester, go back to Blackboard and write my text submission, attach files here. And I put it on my desktop. So I would look for Atwoods Machine Online PDF. And then I'd submit it. And then my instructor would grade it. I'm not going to get too good of a grade because I didn't fill everything in. Anyway, that's your lab for this week. Enjoy.